This lesson has been developed in the framework of SCILED project. Module 2, Footwear Sustainability. Unit 3, Materials and Technologies for Sustainable Footwear Manufacturing.
Lecture 3.3. Testing Standards and Equipment for Evaluating Sustainability Aspects.
This lesson is structured as following. Introduction of some relevant chemicals restricted in footwear. Chemicals analysis, actual limits and how to analyze test results.
1. Introduction of some relevant chemicals restricted in footwear.
Chromium Vi. The chromium normally present in the leather is Cr3. However, by external conditions, sunlight and humidity, the Cr3 could oxidize to Cr5. The chromium Vi is human and environmental prejudicial. Heavy metals are extremely reactive and bioaccumulative. The determination of arsenic, mercury, antimony, selenium, nickel, copper, cadmium, lead, barium and silver by atomic absorption technique, after acid digestion, it's very important because occurs many reactions of skin in presence of these metals. For example, nickel is now one of the most frequent allergy cause in Europe, and 10 to 20% of female population is allergic to nickel. Skin absorption of nickel ions, which are released from some nickel-containing materials in direct and prolonged contact with the skin, causes sensitivity. Further exposure to soluble nickel salts results in allergic contact dermatitis. Formaldehyde. Formaldehyde is toxic and irritable substance. Its presence is normally due to the use on tanning, of leather, preserving and finishing products. The associated techniques for the determination of formaldehyde content are colorimetric and HPLC method. Penta, PCP, tri, DCP, and tetrachlorophenols, TCP, chlorophenols are mostly in gaseous form, can irritate the skin, eyes and skin. The amount of chlorophenols, its salts and esters, can be determined on leather and textiles after water extraction followed by N-hexane phase transfer and followed by acetylation with acetic anhydride. The ortophenylphenol, OPP, is a preservative agent added to leather to protect against microbiologic attack. The acetates of PCP, TCP and TCP and OPP are analyzed by gas chromatography. Azocolorants. Azocolorants are very important once they may release certain aromatic amines. The aromatic amines are highly toxic and are responsible for vesicular irritation and tumors. The azocolorants may be determined in dyed leathers and textiles, with or without polyester. Organotin compounds. Organotin compounds are identified and quantified in rubber materials. These compounds are very pollutant for the environment and can be introduced in outsoles by the pigments. These compounds after extraction are determined by gas chromatography mass spectrometry, GCMS. Phthalates. Phthalates are chemical compounds used as plasticizers in outsoles to confer more flexibility. These compounds are extractable using suitable methods and the analysis is performed by gas chromatography. Dimethyl fumarate, DMF. DMF is a powerful desiccant agent. However, is responsible for allergies extremely serious that could result in hospital internment. This chemical agent is applied directly in any footwear raw material, leather, textile and outsole, or placed inside the package. Allergic dyes. Allergic dyes are a range of dispersed dyes that can cause allergic reactions to come into direct contact with skin. Allergic dyes are basically used in certain products of polyester, acetate and polyamide so intended in patterned textiles, as in dyed accessories such as buttons. Perfluorooctane sulfonate, PFOS, and perfluorooctanoic acid, PFOA, FOS and PFOA and are polymers used promptly in textile and leather articles provide greater resistance to grease, oil and water. FOS may be present in waterproof textiles and, or stain treatments, hydrophobic and oil repellent, in apparel products, home textiles and footwear, mainly. Polycyclic aromatic hydrocarbons, PAHs. PAHs are naturally occurring substances in fossil fuels and may be formed during incomplete combustion of organic materials. Oils contaminated with PAHs may be used as softeners or extenders in rubber and plastic. Some PAHs can be very toxic to aquatic organisms and above certain exposure levels may cause long-term adverse effects in the aquatic environment. Above certain levels, long-term exposure to some PAHs may result in the development of particular cancers, impair human fertility or cause harm to unborn children. Short and medium-chain chlorinated paraffins, C10C13, and C14C17, production of CPs for industrial use started in the 1930s. Currently, over 200 CP formulations are in use for a wide range of industrial applications, such as flame retardants and plasticizers, as additives in metalworking fluids, in sealants, paints, adhesives, textiles, leather fat and coatings. Short-chain CPs are classified as persistent in their physical properties imply a high potential for bioaccumulation. Furthermore, SCCPs are classified as toxic to aquatic organisms, and carcinogenic to rats and mice. SCCPs were categorized as possibly carcinogenic to humans from the International Agency for Research on Cancer, IARC. In 2017, it was agreed to globally ban SCCPs under the Stockholm Convention on Persistent Organic Pollutants. Also MCCPs are toxic to the aquatic environment and persistent. Alkyl phenols ethoxylates, NPO plus OPEO. NPOs are common ingredients in many chemical formulations used to produce apparel and footwear materials. They are widely used as surfactants or emulsifiers in detergents, scouring agents, dye dispersing agents, printing pastes, spinning oils and wetting agents. Legislation around the world restricts the use of NPOs. Leading apparel and footwear brands have banned the use of NPOs in production of their products. NPOs degrade into nonylphenol, NP, in the environment. NP is very toxic to aquatic organisms and may cause long-term adverse effects in the aquatic environment. NP, above certain exposure levels, may impair human fertility and cause harm to unborn children. Volatile organic compounds, VOCs. Volatile organic compounds are chemicals that easily enter the air as gases or vapors from solid materials or liquids. VOCs are ingredients in a wide variety of commercial, industrial, and residential products. Some VOCs are used in adhesives, fabric and leather coatings, screen print inks, and synthetic leather. VOCs may be found as impurities in polystyrene-based resins used in the production of plastic trims. In addition, VOCs may be used in processes such as dry cleaning, as well as finishing and degreasing or cleaning operations. Legislation in major markets around the world regulates or restricts the presence of some VOCs in finished products. Exposure to VOCs can occur through inhalation. They may also enter the body through ingestion of contaminated food or water, or when they come into direct contact with the skin. VOCs, particularly those that are restricted, are known to have adverse health effects on human health and/or the environment. Chlorinated benzenes and toluenes, Chloro-Organic carriers, COC, are a group of chemicals consisting of various chlorobenzenes and chlorotoluenes. COC are typically used as intermediates in the synthesis of other chemicals as well as dye carriers and leveling agents. COC may be present as impurities in chemical formulations of dyestuffs and solvents. Uses in the supply chain within the apparel and footwear supply chains, COC are found in textile applications. COC may be used as carriers during the dyeing process of synthetic fibers, especially polyester and polyester blends. COC are also used as intermediates in the synthesis of other chemicals as well as solvents for dyestuffs and other chemical formulations with high melting points. Legislation in major markets around the world restricts the use of some COC in finished products. Leading apparel and footwear brands have banned the use of both chlorotoluenes and chlorobenzenes in production of their products. Some COC can be very toxic to aquatic organisms at certain concentrations and have potential to bioaccumulate and bioconcentrate cancers. Flame retardants. Flame retardants are chemicals added to products to meet established flammability standards by decreasing the ability of materials to ignite. They are typically used in a wide range of consumer products such as upholstered furniture, carpets and draperies, automotive interior textiles and plastics, consumer electronics, and baby products. Uses in the supply chain within the apparel and footwear supply chain. Flame retardant chemicals may be incorporated into textiles or applied by sprays to decrease flammability of treated products. Some flame retardant chemicals are widely used in plastics, adhesives, coatings and inks. Historically, flame retardant chemicals were used in children's and infants' clothing, particularly sleepwear, to meet safety standards. They are now rarely used to meet flammability requirements in children's clothing and adult products. They should no longer be used in apparel and footwear.
Chemicals analysis.
Conducting chemical tests requires a careful preparation of the samples to be analyzed, material separation, cutting and grinding. If the object of analysis is finished footwear, it is necessary to dismantle it and separate its components individually. The leather has to be cut into 4x4 side squares, or 5x5 cm side squares to subsequently grind to reduce dimensions below 4 mm. Textiles and synthetic materials, and outsoles are cut into 4x4 side squares. Metal parts, depending on their mass, are used just as they are or are broken. If the object of analysis is already the footwear components, obviously the part of the unblocking no longer takes place and advances to the cutting and/or grinding. Weighing. After preparation of the materials, the test sample is taken by accurately weighing a quantity of sample according to the indications of the test standard. Extraction. There are several different extraction processes depending on the chemical parameter to be analyzed. The purpose of this process is to remove the analyze from the sample and bring it into an aqueous medium. We can have several different extractions processes. At room temperature. At controlled temperature, 40, 50, 60, 70 degrees Celsius, in rest. With agitation, rotational, orbital. With different duration times, 1 hour, 2 hours, 3 hours, 7 days. Using neutral solutions, detergent water, buffer solutions, acidic or basic solutions. Ultrasonic extraction. Distillation. Purification and concentration. Routine laboratory work involves purifying, enriching or separating for subsequent analysis. Various chemical and physical methods can be used for this purpose. Among these are absorption, adsorption, chromatography, distillation, extraction, ion exchange, filtration, drying, and many more. Detection and quantification. There are several analytical techniques that allow the detection and quantification of the various chemical parameters to be controlled in footwear. Flame atomic absorption, for heavy metals determination, Figure 1, ultraviolet visible spectroscopy, for chromium-5 and formaldehyde determination, Figure 2.
3. Actual limits and how to analyze test results.
Gas chromatography with mass detector, GCMS, for azocolorants, phthalates, DMF and organotin compounds determination, Figure 3, gas chromatography with electron capture detector, GCET, for penta, tri and tetrachlorophenols and chlorinated paraffins determination, liquid chromatography with mass detector, LCMS, for alkyl phenols ethoxylates determination, Figure 4, liquid chromatography with diode-array detector, HPLC-DAD, for allergic dyes, Figure 5, actual limits and how to analyze test results. The quality of an analytical method developed is always appraised in terms of suitability for its intended purpose, recovery, requirement for standardization, sensitivity, analyte stability, ease of analysis, skill subset required, time and cost in that order. It is highly imperative to establish through a systematic process that the analytical method under question is acceptable for its intended purpose. Limit of detection, LOD, and limit of quantification, LOQ, are two important performance characteristics in method validation. Load and loc are terms used to describe the smallest concentration of an analyte that can be reliably measured by an analytical procedure. It should be clear that limits of detection and quantitation for a given analyte depend on the analytical technique used. This table shows the detection or quantitation limits for various analytes as well as the value of their restriction. This table shows the detection or quantitation limits for various analytes as well as the value of their restriction. This table shows the detection or quantitation limits for various analytes as well as the value of their restriction. This table shows the detection or quantitation limits for various analytes as well as the value of their restriction. To check whether a particular sample is fulfill or not fulfill with the restriction imposed on it, the test result is compared with the restriction value. Test results less than the respective restriction make the sample fulfill.